Sets. We're going to talk about sets and properties in set notation. So I would take a minute and pause this and read over the screen and get a good understanding of what each symbol means. And let's get started. So example 1 says we're going to write the resulting set using the listing method. All right, so let's do that. Look at this right here. See this upside down U? That tells me it's an intersection. The intersection is what you share, what you got in common. So if you're at a four-way stop, everybody crosses here, right? Or I say everybody, whoever crosses here, that's an intersection. You share that particular point. So I'm going to call this group A and this group B. And it's a list, right? Inside of this is elements, and it's a list of elements. So it says A intersects B. Where do they intersect? So let's get the proper notation. I got an X such that X is an element of A. And since we're talking about an intersection, we'll use the word and. X is an element of B. So let's write it as those elements. If you look at them in this group here, I have in A, I have, let me just write it just so you can see it, 5 and 6. In B, I have 6, 7, and 8. And the intersection literally means, what do they share? They both share a 6. So this intersection for A and B is going to be 6. Now, looking at example 2 here, you notice that it's a regular shape U, right? It's faced the way that we're used to seeing it. This is called a union. This means or, okay? And if it's or, then that means we're including everything. So it's like going to a family reunion. Everybody's there is included. You count them all. It could be step, cousins, halves, adopted, whatever it may, you include them all, okay? Everybody at that reunion. So let's call this group A and let's call this group B. So if I'm going to write this as A unions B, again, we're going to have X such that X is all elements of A, or X is all elements of B. And if I was to write this out in the notation, listing it all, I would say that A unions B is, and you only list the number once. And if you notice, 7 is in A and 7's in B, you would not list that twice. You would just list it once. And there's 11 in A as well as in B, so we only list it once. So every number that's in those elements, we just list them once. And that's our answer. Example 3 says that you're giving this whole entire set called U, and then you're given A with a set. And I want to know, what is A prime? A prime is everything, is all elements except for A. That's what A prime is, okay? So what I'm going to do is I'm going to take U. I like to write them to where I can see them up and down, you know, compare them better. And I'm going to write A directly underneath it. So I'm going to go through here and I'm going to mark out everything that's A in U. So I see there's a 16, so let's mark it out. I see there's a 25, let's mark it out. And there's a 36 and mark it out. So now I can tell you what A prime is. A prime is 49, 64, and 81. Let's look at example 4. We're going to refer to this Venn diagram below. And how many elements are in the set A unions B? So looking at that, we're trying to figure out where A unions B at. And if you notice on here, we see that, okay, let me just draw this out. Let's draw it out. Let's label it, okay? This whole thing is inside here is the number of elements of A prime intersects B prime. And then this A circle here, I need to draw better, don't I? Let me draw it a little bit better so, right. There we go. Okay, so this here is going to be A intersects B prime. This here is going to be A prime intersects B. And this here is going to be A intersects B. Oh, yeah. Okay, so now we're set. But the question asks us, where does A union B? So let's solve for it. Well, we know that the number of elements in A intersects B. We know that. It's already given. We see it's 45. We know the elements of A intersects B is 11. We know the elements of A prime intersects B is 17. And we know the elements of A prime intersects B prime is 40. So we know that. So let's just figure out what is A unions B. That formula is going to be elements of A unions B. It's going to be the number of elements of A intersects B prime plus the number of elements of A intersects B plus the number of elements of A prime intersects B. So now that we know that, let's just plug them together. So 45 plus 11 plus 17 equals 43. And that is our answer. Okay, so now let's do example 5. Example 5 says, refer to this Venn diagram and how many elements are in the set A prime. All right, so we're still using the same numbers, okay, but we're looking now for A prime. So I know the number of elements for A prime intersects B is 17. I know the number of elements of A intersects B prime is 40. Let's find A prime. The number of elements of A prime is equal to the number of elements A prime intersects B plus the number of elements in A prime intersects B prime. So what do I have? I have 17 plus 40. That gives me 57. And if you notice, if you look, since we're looking for A prime, right? We was looking for all of them that did not have A involved. Okay. Let's do example 6. It says using this Venn diagram again, we're going to find A. And this notation here is the same as saying A prime intersects B prime. It's the same as doing it like this. Okay, so we're going to find that one. Well, when we find that one with the one given to us, we know that the total, the university elements shows to be 100. Let's figure it out. So let's just double check our math right quick. We get 107 if we add them all. Nope, we get 100 when we add them all up. Okay, so when I take the 42 plus 9 plus 16 plus 33, we get 100, and we're going to call that the number of elements in the whole total, which makes sense. It's the whole total in the box. So what I want to do is take the number of A unions B, and we're going to take and add 42 plus 9 plus 16, and that's going to give me 67. And what do I know? Well, it's everything that right? That's those. So we determine the number of elements from A unions B. Now let's figure out the one that is prime. Well, we did extra work. Some of you, I'm hoping, already caught on. But this is it. If you would look at what we did up here, right here, I wrote it out right there. And maybe my writing's not as good there. Let me rewrite that. So just in case you didn't catch it. And I'm gonna write it on my point here. Okay, there we go. So that one was not hard. We really didn't have to do all that work, but the answer to this one here is going to be 33. But I wanted to show you how to find the total, if you haven't already figured that out, and how we can find the A unions B if we needed to. All right. Example 7 says find the indicated number of elements by referring to the table of enrollments in a finite mathematics class. We're going to let the universal set U be the set of 141 students in the class, A, the set of students from College of Arts, and B, from College of Business, F from freshmen, and S for sophomores. So now we are solving for the, it actually said find the number of F. So we're actually looking for the number of freshmen, right? So to find that, I'm going to look at it. Here's my freshman column, right? So I have 22 plus 53 gives me 75, and that's the number of freshmen. If we wanted to find the number of the arts, right, then we have 22 plus 24. Now, if you want to state 22 freshmen, 24 sophomores, do that too. So now we have 46.